Here's one for you to try. Sketch a graph with all these conditions. We have the limit as x goes to 0 from the left is 2, x goes to 0 from the right is 0, x goes to 4 from the left is 3, x goes to 4 from the right is 0, f of 0 equals 2, f of 4 equals 1. Before you try this, I'm going to give you one hint. Use the vertical line test to make sure that your final graph is that of a function. So run some vertical lines across it and make sure that nowhere on your graph can any vertical line cross it twice. Alright, so pause the video, give this a shot, and then we'll compare notes. Okay, so let's take a look here. So do this in little pieces, at least that's how I approach these. Limit as x goes to 0 from the left is 2. So here we're coming in 0 from the left, we get 2. So I'm just going to draw something like this, coming in towards 2 from the left. As we go into 0 from the right, we're approaching 0 on the y. So something like this. Okay, see, I'm just sketching in those little pieces, right? It's not going to look like a nice looking graph until our very last step. Right now we're just sketching in little pieces. Okay, as we go from 4 to the left, from the left we go to 3. So as we go to x equals 4 from the left, coming in towards 3. So something like this. And as we go into 4 from the right, we're back down at 0 again. So maybe something like this. Okay. F of 0 equals 2. Okay, so that tells us that f of 0 actually is 2. So I'm going to fill that in as a solid circle and put an open circle down here at the origin. Next we have f of 4 equals 1. So that tells me that neither one of my one-sided limits are the actual function evaluated at that point. When we evaluate the function at 4, we get 1. So that point is here, which means we need open circles on both these limits. Okay, so now we've fulfilled all of the parameters given to us in the example. So let's just make it look nice. And here, my graph will look different from yours, right? And in fact, everyone's graph will look different. For the middle section, we can just connect those two together. Maybe put a little blip in there just for fun, right? It doesn't change anything. We're still a function, so that's okay. And then maybe for the right part, I want this to go, I don't know, let's do some exponential type stuff. Right? It doesn't, all those are fine. Last thing is a quick check. I'm going to run a vertical line back and forth over this and make sure it's still a function. Right, so just take a vertical line and you can kind of run it back and forth. Make sure, I guess that line is approximately vertical. Make sure here, okay, here we're only crossing at one point because I made sure and open up this circle down below. The top circle is closed. Even over here where things get really a little dicey, it's only crossing at one point, this solid circle. These other two circles are open here at x equals 4. Right, nowhere else does it cross the function twice, so I'm good to go. So that vertical line, just do that at the end of all these kinds of examples, just to make sure that the thing you've drawn represents a function.